Hi, everybody. My name is Jen Gross. I am the Midwest Regional Director for the University of Denver, and welcome to today's sample class for engineering and computer science. I am going to be behind the scenes, kind of running a few different things here, and we have some faculty and staff joining us today, but what I want to let you know is that you're able to ask questions with the Q&A section down on the screen that you'll find. It says Q&A and it has a bubble. So any questions that you might have, you're able to go ahead and ask them there. We're going to have a chat available. We might post some things there as a reminder to ask questions, or if we want to remind you of some things that are coming up, or provide some links for you as well. And I am going to go ahead and let Matt take the lead and introduce everybody who's joining us today, and I will be in the background, but please enjoy the class.
All right, thanks, Jen. Hi, I'm Matt Gordon. I'm a professor and department chair of the Department of Mechanical and Materials Engineering at the University of Denver, of course. You would know that because that's the school you've been accepted to and are coming to check out. And if you haven't noticed my nice little background that says it, I don't know, 10, 20 times. Anyway, before I introduce more of what I'm going to do today, let me first introduce Dr. Bree Rozelle. We'll start there. I think you may have met her earlier in the day. I'm not really sure what was planned, but Bree, if you want to say another hi, I guess.
So I'm assuming many of you I met during our previous panel, and I am just here to answer any questions while Dr. Gordon is presenting and help you guys out if there's anything on my end that I can do. And so hello, I will, like Jen, kind of hide during the sample class. I'm excited to see what you guys get to learn about. I may or may not know what it is. And then I will be available for questions, anything else you guys need later. So thanks so much.
And I will mention this later because I'm honest. The lecture I will present comes from Dr. Rozelle. So if you do have any questions, I know she can answer them as well as I can. Anyway, we've also got with us a junior mechanical engineering student so that you can, if you've got questions, maybe more from a student perspective. But Aubrey, if you want to just quickly introduce yourself.
Yeah, hi, I'm Aubrey. I'm here to answer student-related questions.
So we've got a pretty good team here, and you know, we're excited. We really wish we could do this in person. It's a little disappointing not to see your faces and ask a little more questions, but maybe we have more people. I see there are 23 attendees. Maybe that's what we would have gotten anyway, but obviously you don't have to travel to join in. So there maybe are some advantages, but we know there are certainly some disadvantages. So I guess, Jen, if you want to share screen, this is probably a good time. We can start the presentation. All right, excellent. All right, so hopefully you're all seeing, I think you have to be because you're seeing what I'm seeing here, so this is perfect. So this is a sample engineering lecture. This comes out of the freshman curriculum. In fact, if you come to DU, no matter what engineering major you pick, mechanical, electrical, or computer, you would be asked to take this engineering 1611 that you see sort of at the bottom, this intro to mechanical systems with CAD. And as I said, this is the course that Dr. Rozelle has taught many times. I think at least once or twice she hasn't, but this is kind of her class. And so this was a lecture we decided would work well in this format. I added this 10-question quiz, so I should get some credit for that. And normally it would be a lot more fun with this little scratch-off thing, but we just can't use these scratch-off cards. I'll just have to sort of describe it. So obviously we've sort of done the welcome. The building you see there is our new, it's not as new as it used to be, but it still feels new. I don't know, is it 4 or 5 years old, something like that. But that's our new building where engineering and computer science is housed. So that's what you're looking at there. And there is a quiz. So if you're thinking, oh, you picked the wrong session and you want out, don't worry. Normally I would say there'd be prizes. It can only be good, but I can't really hand out the prizes either. And we'll talk about combustion engines. That's pretty much the main topic. And then there's a team quiz, which again would be with these scratch off cards, but we'll just have to improvise. So next slide, please, Jen. All right, so we're going to start with the quiz, and I'm going to ask you, even though I'm sure some of you are working together, you're probably, you know, some families are around the same computer. I want you to do this individually. And you can just write down the letter A, B, C, or D for your answer and hide your answers from who's around you. We'll do the team thing later, whatever team you're in. If you're by yourself, you can't really do that. but that's just the way it goes. So there's going to be 10 questions. So answer these first 3, just take a few minutes, maybe more like seconds. And they're all over the place if you're wondering. I don't think anyone's ever gotten 10 out of 10. They're just so all over the place. All right, going to give you another few seconds on these 3. Again, you can just write 1A, 2B, whatever it's got to be. We'll have the same questions. So if you don't remember what A was, it'll be okay. All right, let's go to the next slide. I think the next 3 or 4 questions. So, all right, 3 more questions. And you'll see there's a few of these questions that are related to this talk. And so if you don't know the answer, I guarantee you should know the answer at the end of this, or I didn't do a very good job. All right, let's try the next one. Again, it's really hard to know what the timing is here, so I apologize if you're not able to get to them all. These are the last 4, and 8 just it's indented, but you can see it there about a good job with presidents. And 9, I think it's a good Old Testament question. Wouldn't be a good quiz without that. And then number 10, you get another one related to this lecture. And 7, I don't know how many of you are coming from the Mount St. Helens region. You'd have an advantage for that one. But I suppose you could be in that region and still not know the answer, but who knows? All right, you will see these questions again, but hopefully you gave it your best guess. And again, the idea was this was individual. We're going to do it as a team later. So, all right, please advance to the next one. All right, so combustion engines, this is what you came for, perhaps. Oh, and I should have said, when we get to the answer session or the Q&A session, you've got good access to, me as a department chair, Dr. Rizal, who teaches this course and does all kinds of things in her role as an associate dean, and we've got a great student. So feel free to ask questions that have nothing to do with the lecture and just have to do with what might life be like. Can I study abroad as an engineer? You may have already asked and got these answered earlier, but if you still have questions, feel free to ask anything at the end. Don't feel like it has to be tied to the lecture. Now, if you have questions about combustion engines, that works too. All right, what is a combustion engine? Well, basically, it's a way to convert energy to mechanical energy. So, way early on, caveman type days, at some point, people figured out how to start a fire, and that was pretty good. If you were cold, when I lived in Arkansas and we lost power, that fire was like the greatest thing ever. That kept us warm for quite a while. We were without power for several days. If you're clever, you learn a little thermodynamics, which you will as a mechanical engineer. You will learn how to go from fire to ice. I think that's one of the coolest things. How do you start with a fire and end up with an ice cube? I don't want to give you all the answers. I want to encourage you to be an engineer and learn all these nice little secrets, but it's thermodynamics. Anyway, here's some pictures of some of the early engines and some of the credit to the different people who were involved. Otto is one of the more famous ones. And the Otto cycle is named after him, and we'll go over that. That's the 4-stroke engine, and we'll go into more detail. There's a diesel cycle as well that you may know, anyway, this started, as you can see, 17th century, early 1800s is when this really got going. And I'll tell you, the efficiency of these early engines was not very good. I would ask if any of you know what a typical efficiency of your car might be. And what I mean by that is, if you think about the gasoline we put in the car, it has a certain amount of energy. Like if you just burned it, you could get a certain amount of energy out of it. As you may or may not know, we're nowhere near 100% energy conversion in a combustion engine. We maybe get a third. So maybe a third of that energy in the gasoline goes into making the car run, and the rest of it, you probably know, goes to heat. Your car gets very hot. You have to have a cooling system. If that goes wrong, all kinds of bad things can happen. So anyway, this is where it started. Next slide, please. A little more on definitions. There's a couple different kinds. External and internal. internal combustion engines, Al Gore famously said they're going to be gone, or they need to be gone, if you're worried about the climate. And so, he got a lot of flack off of that. But if you saw General Motors is just committed, I think by 2035, to not make a single combustion engine. They'll all be, renewable or electric or something like that. But anyway, there are also external combustion engines. And showing here is so-called train. In the old days, you see movies, people shoveling coal into a kind of a fire part. But here the idea is the fire is separate from where the piston is, which is going to move back and forth. If everything's go right, the combustion can create high pressure that can push on the piston. And if you do things right, you can make things go. You got to go from linear to rotation. And we'll talk more about that as we go. But this would be an external, where again, the fire thing occurs separately from the piston. Whereas you think of the car, you throw that air and fuel into the cylinder. I guess we might as well go to the next slide because that'll show us one. So here, that upper right picture is sort of the cylinder in your car. So now you mix the fuel and the air together and you ignite it. So now that combustion occurs and it touches the same place that we want to move up and down. And again, that's linear motion. And as you know, the wheels on the bus go round and round. I'm guessing you've all heard that song at one time or another. And so you need something to help convert the linear motion to the rotational. And I think that's one of the questions on the quiz. So internal, just like it sounds, it's all inside. You got gas. Diesel, you've got a slightly different type of fuel, as you know. Hopefully you've never made the mistake of putting diesel engine into a gas tank. It's very hard to do, but a friend in the neighborhood did it recently. It's not good. The diameters of the gas pumps are different because they really don't want you to do that. But otherwise, it's pretty much the same. It's fuel with energy, but the big difference with diesel is you don't need the spark. And we'll get into more of that in other classes. It's just the property of the fuel, and there's some advantages to that. You can get to higher pressure ratios and so on. Thermodynamics, again, is where you get it. But either way, they're very similar. The last one is quite a bit different. This might be like a jet engine. And what's interesting here is you see the intake, you take air in, often a plane's flying, and so the air just kind of comes in by itself. There's still a little bit of compression. That's almost always the case. As you see, we're going to, in the car engine, we want to compress it before we ignite it. Then you have the combustion in the third section. What's a little more interesting about this engine is there is a section where there's like a turbine. You see it labeled there. But in most engines, you would get all the energy out of the turbine that you can. But in a jet engine, and it's really not clear whether there's a jet engine, well, it says jet engine, so it is. You only want to extract as much energy from the turbine as needed to drive the compression. And that will leave a lot of energy left, which then goes out the back as exhaust, but at really high velocity. And that's what propels a plane. But it's a fundamentally different kind of process. But the combustion part, I mean, you don't have the cylinder moving, but otherwise it's definitely an internal combustion engine, and that's why it's there. All right, next slide, please. Okay, one of the key concepts, maybe you've had chemistry, you may recognize this is the ideal gas law. PV equals nRT. Sometimes it's MRT, mass, instead of N, which is the number of moles or just the amount of the substance. Again, if you've had chemistry, you probably know more about this than maybe you want to. Maybe you're a good scientist at heart and it wasn't enough. You just never know. But the key thing here is you got pressure, volume. Again, the amount of the stuff that's in there. R is a gas constant, so we know that's not changing. And then T is the temperature. So if we close off the cylinder, and in your car, if you know the valves are opening and closing, we'll go in that a little bit more. At some point, it's all closed, and that's when combustion occurs. So we know N is constant, the amount of stuff that's in there is constant, and R is always constant. So if you kind of ignore the N and the R and just call it a constant, put T on the other side, we know that PV over T is constant. And so this is a nice little thing to help us work through how things go. When you ignite, for example, the temperature increases. And if the volume doesn't have a chance to expand right away, like it happens really fast, so you can imagine it's constant volume. If that temperature is going up, the only way you can maintain that constant is to have the pressure go up. And we can be more accurate than some of this, but this is really good for you to help predict some of the trends and to begin to understand how things work. And you probably know high pressure leads to a high force. Pressure is basically the force divided by the area. So if you've got high pressure pushing on the area of the piston, that's what makes it go. So, all right, next slide. We're going to use in this, at least in principle. Another key concept, again, we talked about how the almost all engines, I don't know how many of you know about the old Mazda. I don't know if they still got their rotary engine, but Mazda was like the only engine that had the rotary engine. And I think the idea was, oh, if we start rotary to start with, we don't have to waste, by going from linear to rotation. But pretty much every car is linear. The pistons just go up and down. And eventually we want to turn it into the wheels going round and round. And that's where the crankshaft comes in. Could look like a U in some cases. But in general, this is just how we go from linear to rotation. And there are some losses. Even if you got all the energy of the gas that you wanted, you're going to lose some in this process, for example. All right, next slide, please. All right, a little more detail of an engine. This is basically one cylinder. You can see it points to the piston. You got rings. This is always one of my favorite stories. Being older, you get better stories. Because I got to tell you, engines didn't work as well or as long as maybe the way to do it when I was a kid. I had a dad who was a mechanic, so it wasn't as big a deal for me. But man, if you got a car engine to go 100,000 miles, you were doing great. If you can't get 100,000 miles out of one of your cars now, something's really wrong. And a lot of it has to do with those rings. The machining is just so much better now. The tolerances that they can machine to, your car just runs so much better. They last so much longer. Overheating, I don't know if you ever saw the movie Duel. I think it was, I always get them mixed up. It might have been either the guy who did Star Wars or the guy who did, no, I don't know. I get it mixed up. But one of his first movies was on TV. It was called Duel. And the whole thing of the movie was this car overheats going up a hill. And so he has this big problem with a truck. And I just think if you saw that movie now, you go, I don't get it. What's going on? Why is the car having to stop? What is this overheating thing? Cars just don't do it anymore. But when they weren't built quite as well, when machining wasn't as good, you had to worry about things. But anyway, these rings have a lot to do with keeping the oil where it's supposed to be, keeping all the combustion stuff in the cylinder so that it doesn't leak out. It used to be you could always see a car with either blue or kind of blackish smoke coming out of the pipe, and the two colors were significant in terms of what your problem was. But yeah, it just kind of doesn't happen anymore. All right, let's get more to the focus of this. You got an intake valve and an exhaust valve. Intake valve, we're going to bring in the fuel and or the air. When I grew up, all my cars had carburetors where the fuel and the air would be mixed, but almost everybody now has a fuel injection system. So in the intake, only air comes in, and then we inject the fuel when we need. And there's a lot of advantage to that. You can control the exact ratio of the fuel to the air much better, and fuel might combust too early and cause knocking in your car. If you have a diesel car, you're used to hearing this knocking sound. It gets a whole different design. But in a gas engine, the later you can add the fuel, the better. If you can add it right when you want it to combust, you don't have to worry about things going wrong. Connecting rods, crankshafts, engine blocks, that's where the engine block confines the gases, but that's also where you can kind of see it's hollowed out there. The engine block's going to get really hot. Again, we said like almost 2/3 of the energy just creates heat. And so you need to get rid of that energy. That's where your radiator and the whole cooling system comes in. And that fluid will circulate through your engine block in key places to kind of keep it cool. Okay, next slide. Again, we'll go in more detail as we go. Here you got the throttle. The throttle is essentially when you put your foot on the gas pedal, you are connected to the throttle. And that just lets more fuel in or fuel air mixture. This talks about the carburetor fuel injector. Yeah, again, carburetors, I can't tell you, at least with the cars I had, that's probably where I took advantage of my dad, the mechanic, more than any other time was my carburetor would get clogged. The fuel injector is just such a better way to go. Camshaft, that has to do with the timing. As you'll see, you need these valves to open and close at just the right time or things go very wrong. You're probably somewhat familiar with your timing chain. If you've ever done an oil change at like 60,000 miles, maybe 90,000, if you're lucky, you get hit with a really big bill. They'll want to change your timing belt. And you'll go, but that's cost so much money. I don't want to do it. And you can take a chance on it. But if the timing chain ever goes or the belt, usually the chains are better because it's made out of metal, they won't break. But your timing chain's a piece of rubber, high strength rubber. If that thing breaks, then all your valves will start opening and closing at the wrong time. And if the piston, which is just moving really fast, you've ever gotten your car up to 5,000 RPM, 6,000 RPM, that thing is really going fast. Those valves are opening and closing. You don't want that piston slamming into the valves, or you're really going to have an expensive repair bill. So most people will change it, though when you do it, you'll always say, why didn't you build it out of metal? Why would you do this? And oh, and by the way, it'll be an even more expensive bill, because while they're in there, they'll say, now that we got this all taken apart, we probably should change your water pump. And by the way, that actually is a good idea. They're not trying to scam you there for the most part. But my advice to you, get a mechanic you trust. All right, camshaft, again, that's the timing when the valves lift. Oil, this came up before. It turns out it's not a scam to sell you more oil. It reduces friction, makes things last longer. And even oil is so much better now than when I was growing up. And it wasn't just that I had to walk to school uphill in the snow both ways. The oil was worse, and cars just didn't last as long. Okay, next slide. All right, here we go. Here you get the 4 strokes. If you knew it was a 4-stroke engine, congratulations. If not, maybe you now know. And this all has to do with the timing of the valves. Again, a lot of things labeled here, but let's just focus on 4 strokes. Intake. The intake valve is open. The out valve, the exhaust valve, is closed, and the piston will go from the top to the bottom, and it'll draw air in. Intake, very simple. Then we close off all the valves so the air can't go anywhere, and the piston goes up, and it makes a large space into a little space, and we compress it, and it gets hot. And this is where you got to worry about the gas igniting too soon. Ideally, you'd only add the gas now after you compress the air, and you got that spark plug. This is a gas engine. A diesel engine doesn't need a spark plug, but again, I won't go into too much detail there. Become a mechanical engineer, take thermo. I just taught thermo 2 in the fall. We went all over the auto versus the diesel and all that kind of stuff and a jet engine. Anyway, now it's still closed. You ignite it. Now it really gets hot and high pressure, and now it pushes on the cylinder. And this is why the timing is also critical. If it explodes while the piston is still going up, now it's fighting you. You want it to explode right when you want it to go down, and that pushes it down, and that's where you get the energy. And then now you got to get rid of all this stuff that's in there. It goes up one more time with the exhaust valve open and pushes everything out. Quick aside, do people know how a car starts? I love it. This all makes perfect sense, right? I understand that after I ignite the gas, I got all this energy. But before it ignites, I said I got to compress it. How does a car start? I'll get back to that later. If we were in person, you can throw it into the Q&A if you want to throw it in there. And then how did cars start a long time ago? And this is way before. I'm not that old. I'm old, but not that old. I never had to start a car this way. But if you watch a really old movie, you might notice how they start a car. All right, anyway, there's your 4 strokes. Let's go to the next one. I think we get them in detail. So I kind of already gave it away, but this is the intake. As I said, the intake valve is open, and you just draw in air. This is pretty easy. It takes a little bit of work technically, but really a small amount of work to pull that air in. And it says you go from the top dead center, it's called, to bottom dead center. The crankshaft goes from 0 to 180, if you call that 0, but as it goes halfway down, it goes. So next slide. Compression stroke, as I said, you got both valves closed. Now you go from the bottom to the top, the 180 to 360. It's now 1 full rotation. Note, as you'll see, it takes 2 full rotations to make this work, but now we've compressed it all. It's hot, and whether the fuel's already in there because you had a carburetor or the fuel gets injected next, next slide, we now ignite. This is the power stroke. So now the spark goes off, or you add the fuel, whichever you have to do. If the fuel's already there, you just do the spark, or you do the fuel injection and you spark. Gets really a lot of energy released in a short amount of time. And again, it's high pressure, high temperature. We really care about the pressure, but they're related, and that pushes it down. All right, next one. And again, so that's the next 180. So this is now 1.5. We've gone 1 full circle, and now we've gone half more. And the last half, we open up the exhaust valve, and we push this stuff out. And by the way, if you're an engineer, there's so many parts of this you might be interested in. If you really care about climate, and I hope you all do, this is where you really care about. So what are we going to do with all these exhaust gases? And that's why you got catalytic converters. There's a lot of other stuff that goes in your car, and there's a lot of clever chemistry. I don't know how much you like chemistry. I find a lot of engineers don't like chemistry, but chemistry is really important when it comes to combustion. You can ignore it, but somebody needs to pay attention to what's going out your tailpipe, and how good or bad is that for society. But okay, there are the 4 strokes. Okay, I think next one. Yeah, got a nice summary. These are the 4, kind of shows it to you at the bottom, and it just goes over and over and over. And again, you think about the 5,000 RPM, 2,000 RPM or maybe 1,000 RPM is idling. I don't know if you pay attention to your tachometer, but even 1,000 revolutions per minute, this thing's happening pretty fast. And every 2 times, again, it goes up, down, up, down. That's 1 power stroke that we get for every 2 cycles. All right, next slide. All right, this is great. Dr. Rizal found a nice little video thing, and it seems to be working. So we just talked about 1 cylinder. If you're like me in cars, I love cars, but I'm not going to spend a lot of money on cars. I pretty much have all 4-cylinder cars. I'm the one who gets passed when I'm going up 70, and so on, anything uphill, and I don't care. 4 cylinders is fine for most of the time, but you can have 6, you can have 8. This is where you've got the V, if you're into this thing, the V configuration where the cylinders are the V. They can sometimes be parallel just on different sides. My dad being a mechanic, I know I mentioned that, I got to drive a 12-cylinder Jag home. We was a full-service mechanic. Sometimes we would take the cars to the customers. We wouldn't make them come. And so it was great for me. He would say, okay, you drive the customer's car. And I will say, I noticed the difference. As soon as I hit the gas pedal, oh my gosh, did that car take off. And also, by the way, I don't know, I had a 4-cylinder Porsche, a 912. I don't know how well you know the cars, but it's not the 911. That car from a standstill had really get up and go. But when I was going 50 miles an hour, not so much. That's where you need the higher 911 and so on. But again, it was a lot less expensive and easier to work on. But anyway, you can have 4, 8, 12, 6, and they can be arranged in, either in one line or that V configuration. Next slide, please. All right, the camshaft, we talked about it before. There's a good picture of it there. It's just got almost like these egg-shaped things. And basically, if the timing belt is doing its job, everything rotates, and then this thing hits a bump up, which causes a valve to open or close when needed. And again, this thing really needs to be precise, or you can have a lot of damage. And as we talked about, combustion is 1 time in 4 strokes, so 2 rotations, and that's how this thing's set up. And that's kind of why there's 2 of these guys to do the different things. But anyway, you need 2 revolutions to get all 4 strokes and to make it work. And it just has to do with the timing. All right, next one, please. All right, there is a 2-stroke engine. 4-stroke, and we'll do a little bit of the trade-offs. The 2-stroke one is almost hard to, the picture, it's really quite clever. And basically, the 2-stroke engine does 2 things at once. And if you look, I don't know if I've got the pointing capability, but if you look at sort of the blue areas of it, you can see, yeah, that's great. You're pointing there, yeah. And a little bit to the left of where you're pointing, the really thin part. Yeah, that part, notice how the cylinder blocks it. Right there, it's being blocked. But if the cylinder goes a little further or a little lower, it'll be open. And it'll allow the one area to reach the other. It's a really clever design. And that's where, yeah, as it goes up, it both draws stuff in as it puts out the bad stuff. It's terrible for the environment, right? Maybe terrible is too strong a word. But the combustion isn't as complete. You don't push out all the bad stuff before you bring in the new stuff. But now on a 2-stroke cycle, for every single rotation, you get a power stroke. And so you get, in a sense, twice as much energy out per time as you would if you had to go 4 strokes to get 1 combustion thing. This is really important where size might be an issue or weight's an issue. So you see it in lawnmowers, some motorcycles, chainsaws, and it's a really clever thing, but it's just hard to make this too efficient. If you really care about the environment, you really want the 4-stroke, or you really want electric. But that's a whole nother lecture that we won't get into. But you should know about the 2-stroke. It's still an internal combustion engine. It combusts right next to the thing. So it's a good thing to know about. All right, let's go to the next one. All right, so yeah, comparison. I sort of said some of these, the 4-stroke is what you're seeing on the right. More complete and efficient combustion, because you really can push the stuff out instead of trying to do 2 things at once. Less noise pollution, multi-cylinder engines typically, but 2-stroke, again, it's less efficient with higher emissions, but it's cheaper. Have you heard that? Have you ever seen our world go, oh, just because it's cheaper, I'm going to do the right thing? Yeah, I hope we get there, but unfortunately, society's not quite there, but maybe we're moving there. It is cheaper and it's better for smaller applications because, in a sense, it weighs less because you get more power out for the same amount of weight because, again, you get twice the power strokes for the number of times. All right, we're nearing the end. Let's go to the next one. All right, we are at the end. Okay, so what we can do, we can take a second here. This is probably appropriate. Why don't we see if you got questions related to engines? I promise we still got plenty of time. We're only about 30, 35 minutes. We're going to have you do the quiz one more time, but in groups, and then we'll give you the answers. But for now, let's see if you've got questions related to something in this lecture. And again, we'll have time for more general questions about engineering. And it's okay if you don't. Could mean I did such a great job you have no questions. Could mean I did a terrible job and you don't understand any of them, you don't have any questions. I saw earlier, I think there was a question that got answered related to someone who might have been in the wrong room. They were more interested in game development, and that's the same building I showed you, but yeah, unless you kind of double major. All right, I think we know if someone was typing, or I don't know, but we'll wait another little bit, see if any questions are coming. Yeah, so if you're gonna ask your questions, yeah, do it in the Q&A part. Maybe you kind of have a question. Oh, there we go. So are all engineering lectures going to be like this format? Any lectures that are structured different? So yeah, in this one, with COVID, you'd actually find that most lectures are more like this than not because we're often working remotely. But when you're in person, you're going to see a wide variety. We weren't able to put you in groups and do little activities. Dr. Rizal is one of the better ones at that. You're not just going to sit there and watch a slideshow. It's generally going to be more interactive. Some professors will do that, but there'll be some of this, and then there'll be other things. You might have a lab class where, of course, it's very much hands-on, but we're all trying to make it more hands-on. But during COVID, it's been a challenge. I'll let Dr. Rizal answer. In fact, I don't know if you want to answer now, but she's had to teach some lab classes. She's just been experimenting all over the place. Do you want to answer that one? I know you do some innovative things.
Make sure my video was there. Yeah, so I think, in what we now call normal times, which I don't know if they'll ever be normal again, obviously all faculty are going to have really different ways to lecture. I actually think most faculty, at least in engineering, I think maybe more so in computer science, don't tend to go like the PowerPoint route as often. Like we definitely do to show different examples or figures or like this for images. There's sometimes it is drawing on the board. Sometimes it is, activities during class in between. But as Dr. Gordon mentioned, I taught remote, kind of a hybrid in the fall of our first year course, which is where, this lecture slightly different these days, just because I was teaching it hybrid, where I had students that were remote, students that were in person. I had labs that were in theory in person, but I had students that needed to be remote, so we switched them that way. So I think you're definitely going to get a variety. And then we also, if you were in the lecture earlier about engineering, I discussed, we have classes that are strictly design classes where, it's not lecture. It is you are working on a project, working together, hands-on in the lab, learning new techniques. In comparison, you might have some that are much more just, the lecture style. So we definitely vary a lot. I think we've actually learned a lot this past year about different ways to use technology and to make classes more engaging and to have options for students that maybe can't be in the classroom all the time. And so I'm kind of hoping that we end up at the end, we still have everybody in person, because that's still, I think, is the best way to teach and for us to communicate with our students. But we've definitely gotten some new skills that we're hoping to add. So really what it comes down to is there's a lot of variety, but I think our faculty are pretty good at engaging students and making sure you all feel like you're part of the classroom.
Yeah, perfect. And, actually, I'm a board person, so I like to write on the board. I think it helps slow me down. PowerPoint, you can tell I'm a fast talker. If I'm writing on the board, I think it helps pace me, but I also try and get a lot of interaction. If I'm doing an example, I don't like it when the class just watches me. Anybody can watch me solve something. I want the class to take a whack at it as we go. You probably won't be able to do it perfectly, but hopefully you can do some of it. And I think you learn better if you're more engaged that way. But you'll see a wide range. I think Bree sort of mentioned this, but maybe not directly. I think we're all hoping, and we're pretty confident by fall, we're going to sort of go back to normal. But she really said this: normal isn't what we think it was. I think we're going to try and bring in the best of what this allowed us to do. There were some advantages. But get back to being live, but maybe keep some of the features that we picked up that were helpful. But it'll be an evolving thing. So, but yeah, spring, this quarter coming up, we're in right now, and then spring, which has nothing to do with you all, it's pretty much fully online. Well, hybrid, there's some hybrid, but by fall, we think we're all vaccinated and ready to go back at it. Okay, next slide. I think it's going to be the quiz. And again, we can get back to this. So now you can work as a group. So if you're in a room with more people, feel free, because one of it's the power of groups. That's why teams and diverse teams. This isn't the best example of it, but these questions are so all over the place. You're going to do way better in a group. Maybe someone knows something about The Simpsons, but maybe not everyone, and your team is more likely to be able to answer them all. But now write down your answers, and I'll go over them. We may need to go back, Jen, so that I can talk about the answers, but I'll mention that. So give you another little time to get your final answers as a group. You can now discuss. That's the main point. And hopefully you noted what your answer was individually, but if you forgot, that's fine. So you can really see, I think it'll come out clear that the team is much better than the individual. All right, let's go to the next one again. It's hard for me to get the timing right, so apologize if it's not so good. And hopefully 4 and 6, you know the answer to from this lecture. All right, at the risk of being too quick again, we'll go to the last one. And this is where we'll see how good your team is. How many of your team was alive when Eisenhower was president? She might know that, any of these presidents. Let's see, I was alive for all these presidents, just barely D. Actually, I take it back. I wasn't alive. He was killed in 63, and I was born in 64. Okay, so let's go back 2 slides, please, to question 1. And I will give you the answers and you can kind of score. It's way more fun with these scratch-off cards. The whole point of these scratch-off cards, I'm just going to make you feel bad that you didn't get to do it. But you can email me and I can tell you how you can buy them if you want. So you'd have this scratch-off card. You'd have to have a coin. And if you thought the answer was A in one, you'd scratch it off. And if you did think it was A, you'd find out you were wrong. There's no star under there. And so now the team would get back together and you'd yell at each other. Whoever thought it was A, you'd say, I knew you were wrong. And that's part of the fun, by the way. And then you decide, okay, well, are we going to do B, C, or D? And maybe the group says, well, let's do B. And then it turns out you'd be wrong again. And then there'd be some more yelling, blaming whoever decided that you should do B. And then you'd go to C, of course, and you'd still be wrong. And then when you scratched off D, you'd see a star. And it's just like, it's a great feeling when you scratch it off. It's like the lotto tickets. I don't use them a lot, but when you scratch off and win, it's exciting. It gives you that kind of fun. So when you scratch off D, you're going to see a star. And then you're like, yay, we won. And then, you pat everybody in the back and, the person says, I told you it was D. It's way more fun than me just telling you the answer was D. But anyway, the answer is D. All right, number 2, same thing. This one, a lot of people think it's the USA. I remember this one. This was one of the few years USA didn't win. And maybe you remember the USA didn't win, but who did win? Turns out it was Argentina. So if you said A, give yourself full credit. Oh, and the other thing with the scratch off is you still get points. You get more points if you scratch it off on one try. You get less points on the second, and so on. It's a real fun tool, and it's hard to simulate without the cards. Plus, you got that discussion so important because now you can say, yeah, I knew it was Argentina, but yeah, when you scratch, you can't pretend. Okay, number 3, that one is B. It's the sense of smell is the correct answer. So let's go to the next slide. 4, again, I hope you all got this one. It's A because it's pretty. No, is to translate. B and C you can mix up, but remember, you want to go from linear. That's what the piston goes linear, and we move to rotational. So the answer in this case is C. 5, I don't know. I knew this one. I know Gene Simmons, but when I was growing up, Kiss was a pretty big deal. They're still kind of around. I think you see them when they're in their makeup. But the answer For 5 is C as well. KISS is his band for Gene Simmons. 6, not combustion. It's the ceiling fan, right? That's just all electric. That would be, you'd probably die in your sleep with the emissions if you had a ceiling fan. But anyway, lawnmower, jet engine, chainsaw, that makes more sense, but a ceiling fan is the correct answer. 6A, so let's go to the next one. 7. So 7, I don't know how you know this, but every now and again, some people who are good at this, maybe they live there. I would not have known this one for sure, but this one is Cascade, and Cascade Range is where Mount St. Helens is. And the president, this one is Nixon. Nixon's got an interesting story. He was a vice president, and he lost a couple times, lost to Kennedy. That was the famous one. That was like the first time there was television for the debate. And Kennedy just seemed to know how to do it. Nixon looked like he was kind of sweating under the lights. And he was like, okay, well, I'm done, right? I mean, I lost the presidency. It's over. And then things changed, and he won later. He succeeded Lyndon after Kennedy got killed. Lyndon Johnson was president, and then Nixon won in '68, and then you got Watergate. And it's if you like history, there's a lot of good history there, no matter what you do. All right, the next one's impossible. I think people who even up on the Old Testament don't know this. And this is by far when the scratch off. This is almost always the one where people get it last. But the answer is D. It's 150. And I haven't verified these. So if you go in the Old Testament and you find out it's wrong, you can email me and I'll be happy to change it. But I got this from what I think is a very good source on bar trivia. And I'm sure the internet is never wrong. Or is it always wrong? Or anyway, last one is another one. Hopefully you got what is the purpose of the oil? And I love D. Again, I think I got these from Dr. Rozelle, so she gets full credit for that one. This one is B. It helps remove friction or reduce friction, the moving parts. The heat sink one could be tempted. You know, it has to do a little bit maybe with cooling, but that's not its real purpose. It indirectly is involved in that process, but it is B there. So, okay, we are completely done. You now have the answers. If anyone wants to chime in and just say that anyone, I've never had a 10 out of 10. So, you could just, you could be just saying it. I don't know for sure, but that scratch off card doesn't lie. And we grade hard. If you even slice it a little bit, we count that against you. Some people, they move the stars around. The company that did this is genius. I don't know if I got any teachers in the group, but if you are teaching, these things are just amazing. They're not very expensive. They're fun. But yeah, because people worry that they move the stars around. So people can't say, oh, I know where the star is. I'm going to just do a tiny little thing they'll never notice. Anyway, they're a lot of fun. And there's different formulas. You can get them for like 3 answers, 4 answers, 5 answers. You can get a card. I get the card that only goes 10 deep. It's perfect for this. But you can get them to go 25, 50, and 100. If you want to contact me, though it may take me a little bit because I'm not in my office to figure it out. But that's a complete aside. Okay, questions of any kind. Study abroad. Just anything you want to ask about. Again, I'm sure they were all answered before because Dr. Rozelle does a good job. You did run one of the earlier sessions, right? All right, then I know she probably covered everything you could want. But maybe you weren't paying attention because you were at home and the dog or the cat jumped on your lap and you missed an answer. I don't know. But anyway, the floor is yours. And we got Aubrey. If you want to just hear, I'm tired of hearing from faculty. They make everything sound good. I want a student to tell me the truth.
Gordon, I tend to speak quickly, so I'm sure there are things that could have slipped by earlier.
So that might be a good thing because I'm known to speak fast, but I don't know which one of us, we should get some outside person to judge. Yeah, we're both pretty excited. We're high energy. I think that's kind of where it comes from. I think it's a good trait in the long run, though I can't tell you how many times my mom says, but you will speak more slowly when you're talking to actual people, won't you? Your parents on you brief for that as well.
Yes, for sure.
Maybe Aubrey would like to give a little bit of insight from just her experience as a student and if she came in directly in engineering or how it kind of evolved for her.
That's a good question. Don't wait for the question. Aubrey, tell them your experience. It's a good one.
Yeah, I came in as a mechanical engineering student. I was more interested in electrical. Then I decided that I didn't want to do electrical. and I stayed mechanical, and I love it a lot. It's really nice. My classes are all really small, so I get a lot of support from my classmates and my professors, and I feel like I get to do a lot of cool things and learn a lot of cool stuff. So, yeah.
We got two questions. I think it was Aubrey who brought out the best of you. One had to do with study abroad. I gave a yes with 3 exclamation points. This was a real sore point for me when I got to DU, but in a good way. So I studied abroad. And I'm not bragging here, I'm just telling you it can be done. I was pre-med in addition to majoring in mechanical engineering. So you're asking me if you can go abroad? The answer is of course, yes. I went abroad. But anyway, when I got to DU, I was very disappointed. That's the sore point. When people would go to lectures, they say, oh, if you're an engineer, you probably won't be able to go abroad. And I said, stop that. Maybe that was the case, but ever since I've been here, we are a good study abroad school. Now, do we get the 70, 80% that DU brags about? No, we're bringing down the averages, but we're at about a third in a good year. So it's very easy to go abroad as an engineer, as long as you just don't get behind. Many of you will come in with AP credit and you'll start ahead. You might go to summer school. They'll definitely talk to me about that. I would discourage it. I don't discourage you being productive in summer. I definitely recommend you don't just sleep in and do nothing. But if you could get a job, if you could do undergraduate research, or you could take a class. Class is the one I'm going to say scratch off your list. No company ever says, you know, if only you took one more class, then maybe I would hire you. But companies all the time say, I would prefer to hire someone who has some internship experience, who has some research experience, even study abroad. I came back from my most fun quarter ever, no pre-med, no engineering. I'm in France. It was amazing. And I come back relaxed, you know, kind of, just my mind's clear, and I'm told I'm more employable. So anyway, we make a very good effort to make sure that you can study abroad. So that's a big emphatic yes. Are either faculty involved in research? We're both very only tangentially. Dr. Rizal is on the teaching faculty line. And so I think through Grand Challenges, I don't know if you have a Grand Challenge student though. You have a Grand Challenge student?
One right now, but I do work with a bunch of Grand Challenge Scholars students on an outreach project that's research based right now. So I'm sure Dr. Gordon will go more into his, I am teaching track. I did research, I loved it, but I actually love teaching more. Sometimes that's, people think, oh, you're in teaching track, that means you weren't good at research. It's actually just because I really love teaching. And so my background, now we do research in like pedagogy, like Dr. Gordon and I have written some papers for American Society of Engineering Education, and we've done projects. So I've been fortunate to actually be able to do research now based more in the teaching side of things. And I do like to help students who want to, do research outside of, in other labs through things like the Grand Challenge Scholars Program, et cetera.
Yeah, exactly. And I since I became a department chair, I've done a lot less research. I've been tangentially involved with a couple of other things, but this is the nice thing. We all have PhDs, and this is where she's right. Teaching faculty in some circles has a bad reputation, and it's horrible. So it's ridiculous. We all got PhDs. We're all very good at research. We just try and do what we're best at. But we've got another Dr. Roney, who's another teaching faculty, an amazing teacher. He's more involved in research because he chooses to. It just works out for him. It has nothing to do with whether we're good at it or not. And we all can advise you to get involved in research and help you make that decision. Should I spend my time in research, or I got a chance to do an internship? I'm working through my own kids right now. My daughter at DU, I tried to get her to apply to an REU, research experience for undergrads for the summer, but she's more interested in an internship. My point to her was apply to both. You get more options. But anyway, these are all great experiences. So yes, we know about research, even if we're not as high research folks as there are. Let's see what else we got. So okay, that one's, yeah. Will the student have an advisor in the School of Engineering as well? Yeah, so this is another, I wouldn't say sore point, but you're gonna get a freshman seminar advisor, and they're great. But when you major in engineering, we insist, it's really in your best interest to also get an advisor in parallel from our school. You're gonna see me and Dr. Rizal in your first classes in the fall. And so we're almost always the most common ones. You're gonna meet an amazing electrical and computer engineering faculty in the winter, Dr. Gonzalo Martins. So we're gonna introduce you to him in the fall because you need to know who he is. Between the three of us, you've got everything you could want covered, but you're going to get all the engineering advising you want, but you're also going to have a freshman seminar advisor. So there will be two. Do students stay on campus to do research over the summer? Yeah, COVID's a little bit differently. This last summer wasn't so great, but in general, absolutely. And this REU I told you about, research experience for undergrads, it's a summer program run by NSF, the National Science Foundation. DU has one, but they really want your own school students to go. So DU's goal is to get non-DU students, but that means you can go somewhere else. They're in Hawaii on occasion. I don't know if anybody likes Hawaii. I do, if that isn't obvious. But I think it's probably smarter to pick on topic and not location. But sometimes you get lucky and you get the best of both worlds. We had a student, this was about 8 years ago when I was first year, she was in love with cars. And we teach you all about cars. I taught you a little bit right there, but we're not a car school, okay? So if you really want to go and work for a car company, you would benefit by working with a car company over the summers. And this one student, she got herself an internship with Ford or, one of the big three, and she got herself a full-time job, in the Michigan area. So she did an REU to get herself started. There's lots of ways around that. Will a student have an advisor? Yeah, and the freshman, I just did that one, that's right. Common companies that recruit, that's all over the place. That's one thing I would say, Colorado doesn't have a bread and butter thing. Like if you go to Michigan, you got the car companies. We got some aerospace companies. We got a lot of communication companies. We got transportation. I think our students go all over the place. We get some students. I remember another female student who was from the Minnesota area, and she on her own, I think, I'm not sure they recruited here, but she got a job with what's the Snowcat? I think that's the name of it, Snowcat. That's who she wanted to work for. I think they're based in Minnesota, and that was perfect for her. Aubrey, you've been probably going through the system. What is your sort of take on when you think about what companies come here or how that works? I think we got a pretty good system, but I know it still takes some work on your own. We don't do everything for you. But anyway, let's get the student perspective on that one.
Yeah, I know Lockheed is pretty popular. I think there's a lot of students that do internships with Lockheed, or we did that teacher or professor from Lockheed. So that's the biggest one that sticks out to me. I think you're right with a lot of aerospace companies usually.
Yeah, I know we get reports every now and again, like they say where our graduates went, and some schools it's wow, they just get this huge number in a couple companies. We get, part of it because we're small, but we just get a handful here and there. Bree, you got something on this too?
To say, so one benefit, kind of a strange silver lining of actually the kind of COVID era that we've had, is that normally a company would say, oh, do I want to send someone to a school in another state or something like that as far as recruitment goes, but they have been doing a ton more virtual recruitment events for students. And our career services, we have a wonderful career services department. What they do is incredible. And we have ones that work specifically with both Ritchie School and NISM. So they're very STEM specific. They have been out doing such good outreach to companies to do virtual sessions with our students. And these are companies that normally, they're based out of California or Minnesota or somewhere else that may not necessarily want to send someone here for a career fair. Now our students are having these opportunities to get to know these recruiters and to, learn more about those companies. So actually, I'd say we're in kind of a golden era of that, is that our students can, we're so used to doing things remotely that is a really great piece of that remote, the good piece of learning to do things more remotely, is that our students are getting those opportunities as well.
Perfect. We got another question related to help. I would say this is, I think, DU's strength. I think our faculty as a whole come to DU because they like teaching. They know there's going to be more of a student teacher interaction. And that's not just like Dr. Brazil, who really wants to teach. I think even our research faculty enjoy teaching some undergraduate courses. Now, they're not going to teach as many as Dr. Brazil because they just don't want to do it that much. But that's one way. But we're really good on the disability side. We're probably the best school ever. If you've got any learning disability, we've got one of the best programs in the country. The number of students who get maybe 50% more time on their test or a little extra help with whatever, it's just not a big deal at DU. But let's just assume you're none of those categories. You're just a student who's maybe struggling a little bit. We've got a lot of free tutoring, and that's outside of office hours. That's both the professor directly. There's a lot of schools where you don't necessarily go to the professor for help. You go to the TA, you go to students and so on. And I'm not saying that's terrible, but I think what's great about DU is you get it all. You can definitely see doctors. You can come to my office anytime, but we're often going to have TAs, and that's just for that class. There's a lot of TAs essentially set up in the library. It's remote now, where I know Bree's the one who helps Hiram now. We send 2 or 3 of our undergrads, our stronger undergrads, and they have lots of hours in the library, virtual I think at this point, but you can go anytime and you can ask them anything. This is a junior and senior engineering student, and you may be struggling in math and think, I got to go to the math people, but you may find that an engineer can help you better with your calculus problem than a math major. And so what I tell students is don't just go to the math person. I would certainly go to the math person, but if you're not getting the help you want, try an engineering student. All of us, well, we probably forget some of the math they teach you, but you can come to our, I've had people come to me for classes I'm not teaching. So I think we're very good on the support structure. Now this is all free. Everything I've told you about is free. But if you really still are struggling, we can then recommend tutors. There's groups that will help match you up if you need to get that extra help. We're really good about helping students get through, but we've got a very forgiving drop policy if you need. But because we're small, we often don't repeat our courses more than once a year. And so we're very good about giving you every chance you can to pass that time and then working with you so you don't lose a year. I've had so many students come in and say, oh, I got to drop this course. Have I just lost a year? No, we figure it out. We've got athletes who can't take courses at certain times. Forget about the people who have to drop. I had a professional snowboarder. I'm sure Bree did too. We all have the same students. But she's like, for her first 2 winters, she goes, I'm not going to take any classes. Okay, well, we figured something out. But it wasn't a punishment 5th year. It was a plan that allowed her to try out for the Olympics and do the things she wanted to do. So I think the fact that Maddie's on this line, another former student, by the way, but she's a little further past. She may not even remember what it was like to be a student at DU. I bet that's true. But let's see, what is the average class size for engineering? No class can be bigger than 100, but most of ours, we might get 70, 80 freshmen together, but even that we split into 2 sections to make it easier for enrollment. My Thermo 2 class had like 30 people, but then we bring students together in a good way for our project courses. So they might have 60 or 70. So, you're going to be somewhere between, I don't know, we got a tech elective with maybe 10, anywhere between 10 and 90. That's a wide range. I'd say average 20 to 30.
Well, average of the Ritchie School is about 27 right now,
Okay.
but that's broad. And that doesn't even count like labs, which maybe have 15 to 20 students, some even smaller, like some of our capstone lab, those have like maybe 12 in a lab section. So yeah.
Addie's saying she does remember, and it was great. She's not, yeah, this is where it's bad. I can't remember exactly. I'm going to say you graduated 2 years ago. Bree seems to remember better. This is where it kind of blends together.
2019.
2019. Okay, so yeah, 2 years ago this spring is what I say, a year and a half in the middle. That makes it tricky. And Aubrey should graduate a year from this spring. So all right, I think we're nearing the end. I don't know, it's 3:59. Do we got time for some quick ones, or is this a good time to wrap up? I'm going to defer to those in charge.
I think it's a great time to wrap up. I love your energy and excitement. I hope that everybody enjoyed this sample class and this session. There's a lot to take in. So I know this is being recorded and will be available later on if you missed some things or want to go back and have a look and see if there was anything that you wanted to review again. But thank you so much for our professors, Matt, Gordman, and of course I took my glasses down. So and Bree, and then also Aubrey, thank you so much for bringing in a student perspective. We really appreciate it. So we are at our time. Thank you so much for joining us. And if you have any questions, please reach out to the admissions office or your counselors. We're here to help answer those. I hope that you got a good deal of information from this entire Journey to DU week. Again, most of those sessions have been recorded, so you'll be able to go back and watch those that you might have not been even able to attend. So thank you so much and have a great weekend.
Yeah, feel free to reach out to me directly if you need to, or they can match you up. And I hope to see you all in the fall. That's probably unrealistic, but we can hope.